If you want to change this to this, stay with me till the end of this video. There are lots of tricks in the process. I'll start with removing tiling effects. Then we're gonna add nanite tessellation and finally create a dynamic wetness effect around the ocean that moves with the water surface. Alright, let's dive in. We'll start with a surface texture from Megascan, which includes our necessary textures and a material. Open the material and change the tiling to see what you get by default. For instance, a value of 2 repeats the texture 2 by 2 in each axis of the UV. If you increase it to something like 50, you can clearly see the annoying tiling effect. Now let's create a new material from scratch. I'll name it Sandy Tutorial Matte and drag all the textures we have into it. First, connect the base color. This is what you get. To remove tiling, we'll use a technique called texture bombing. If you're unsure about a node, connect it to the base color to see its effect in the viewport. We'll do this frequently in this video. Hold 1 on your keyboard and click to create a constant node. Change it to a parameter and rename it. Connect this to the tiling input on your texture bombing node and hit apply to see the effect. As you can see, texture bombing blends the same texture in various directions to hide the tiling. Now you can connect your texture. Because it should be a texture object, right click on the texture and change it to a texture object. Connect it and then hit apply to see the difference. Repeat this process for other textures. Remember, normal map blending differs, so use a boolean node, set it to true and connect it to isNormalMap. In Megascan textures, the third one, which ends with ORDP, contains ambient occlusion in the red channel, the roughness is G, and the displacement is B. Use the breakout float 3 components node. Now you can connect each channel to the respective node. If you can't see the effect of ambient occlusion, switch the view to material ambient occlusion. If everything is white, it's not working. To fix this, close Unreal Engine and navigate to your project's config folder. Open the default engine.ini with a notepad or anything you want. Find renderer setting and add r.allow static lighting equal false. Save, close and reopen your project. Because I want to show you the difference more clearly, I simply multiply it to 0.5. If you prefer not to disable static lighting, you can multiply your AO texture by the base color, which is not so realistic, but it's better than nothing. In the multiply node, it doesn't matter which one is connected to A or B. Now you can connect your roughness and displacement channel. If displacement is unavailable, I'll show you how to enable it shortly. Now let's compare our material to the original. As you can see, there is a huge difference even now. To enable displacement, close the engine again, open default engine.ini again and add these 2 lines to it. I put them in the description so you can just copy and paste them. Now you have the option, but it is disabled. In your material details, search for nanite and enable tessellation under the nanite tab. Hit apply to see the changes. Now, all we need to do is to tweak the magnitude of the displacement. You can try different values to get your desired amount of displacement. As you can see, now we have this insane amount of detail. If you know how to make a landscape material, you can do the same for it. Now, let's move to the next part. For the water, I used Unreal Engine's water plugin, which comes with it and doesn't require to download anything other than the engine. Hit enable and restart the editor. Add a plane to the scene and find this water underline far mesh material and assign it to the plane. Change the size of the plane and you have the water, but the ground around it should be wet. Before proceeding, you need to understand some important basics about world position. In another level, I have a cube positioned at 0, 0, 0. And I've assigned a new material to it. If you search for world position and add it, you'll see a red node called absolute world position. We only want to work with the z-axis because the ocean level can only move in the z direction. By connecting it to the base color, you can see that any pixel higher than 0 in the z-axis is white and any pixel lower than 0 in the z-axis is black. This is in world space, meaning it is not related to the object itself, so moving, rotating, or scaling your object does not change the rule applied by the node. To move the line separating black and white, you can add a positive or negative number to it. Remember, adding a positive number makes it think the object is upper. So you need to lower the object to see the line. Conversely, a negative value makes it feel like the line is higher. So you should move your object higher to see the line. Now, as you can see, the line is not so sharp. You can extend this smooth transition by dividing the position by a number. Higher values give a longer transition between black and white. The gray transition comes from values between 0 and 1. The base color translates 0 and any number below it to pure black, and 1 and any number above it pure white. Alright, back in our main level. Add a cube where the water and ground collide to find the z value of this part of the world. Use the inverted value in the add node to see the effect. Once satisfied, connect the node to the roughness so that black areas look wet and white areas look dry. But we need to use the roughness texture to make the wet parts look better. You might consider blending these two roughness values by multiplying them, but the problem is we cannot see lots of difference and we need more control over what we are doing. Using another blending node like blend screen can produce incorrect results. In a near future video, I will explain how these blending nodes work. But for now, let's see how we can solve the problem. Let's connect the roughness texture to a blend screen node, add a constant value and observe the changes. Then connect it to a multiply node with another constant value to tweak the effect. Finally, connect the result to our world position using a blend screen node. The result is much improved. Before going any further, organize the nodes by selecting them and pressing C on the keyboard. Now, as you can see, the tops of the stones are wet. We can refine this effect using the displacement texture. Connect the displacement texture to the base color to see that the tops of the stone are brighter. Use blend screen node to darken the dark areas. If you use multiply to connect the result to the roughness nodes we had, it will darken other parts of the material too, making it look wet even where there is no water. Blend screen won't provide a satisfactory result either. Double click on this line to make it easier to reconnect the real base color. Notice that height blend screen value is not blending well. Sometimes the tops of the rocks are black or wet, while other parts are white or dry. To fix this, multiply both results by -1 to invert them. Use blend screen to blend them and invert again by multiplying the results by -1. This produces a beautiful effect. If you don't know how this part works, you can subscribe to see the future videos in which I'll cover blending nodes. Now connect it to roughness and restore the base color. You'll see a significant improvement. I'll change some values to show the effect and control you have. Don't forget to organize your material periodically to prevent chaos. To link the wetness to the ocean, we need to create a material parameter collection or MPC. Inside it, add a vector parameter. Change the name to something like ocean level. And as you can see, the default values are 0. Hit save. We want our MPC to replace this added value of world position. Now drag the MPC into your material, click on it, change the parameter name to ocean level. You can connect it to the add node, but this is not what we want. You need to break it to vector3 like what we've done to our ORDP texture before. We typically use B channel for the Z-axis. Apply the changes and adjust the B value in the MPC to see the effect. However, we want the ocean level to control this automatically. Create a simple blueprint. Choose actor. Give it a suitable name and double click on it to open. We don't need anything in the viewport or event graph. The construction script tab is all we need. First, get the Z value of the actor's position. Right click and search for get actor location. Now, right click on the return value and split struct pin. Remember, we had to use the inverted Z value in our material. You can do it here by multiplying the Z value by -1 or in the material. No difference. Next, search for set vector parameter value. Choose your MPC and the parameter name. Right click on the parameter value. Again, use split struct pin and connect your actor Z location to parameter value B. This will change the B value to the actor's Z value. Hit compile and drag the blueprint into your level. As soon as you do this, you can see it is working like a charm. Copy the Z value of your water plane and paste it to your blueprint. Now you can put the water plane under the blueprint. So whenever you move your blueprint, the water moves accordingly. If the plane is static, you can't place it under the blueprint. To get more control over the wetness height, you can add another add node and a parameter to offset the wetness. In the next video, I'll show you how to speed up your movie render queue renders without sacrificing quality. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more Unreal Engine tips and tricks. See you next time.